Okay, so now a quick review of the basic attack flow as the tool stands now. I send my initial request. If I get a 500, I don't want to talk to the server at all. I don't care. I'm just going to drop it. I want a legitimate request, and then we'll begin the attack phase. If it's a valid response, then I'm going to go out and I'm going to begin the attack and start sending these malicious strings. So now we've got the 25 threads running in the background, and what I want to do here is now we're going to run one. I switched this version of the script up a little bit so that it's verbose, and assuming it does work, it should be showing us some data, which it is not showing me right now. There we go. Okay, so we're going to kind of let that run for a minute. So essentially what it's doing is it's taking this website. I do not know why it's going so slow. It's just the way demos work. There's different timeouts. This website that it's attempting to visit may or may not be up. It's timing out. I was hoping it would go a little more quickly. But essentially what we're doing here is I'm cycling through this list of random URLs. I'm sending my initial request. In this case, it's stuck trying to figure out if that URL exists. And it'll time out or move on to the next one here soon. And so from there, it's going to go through once it gets the request, and it's going to begin its attack. So we're going to give it a minute there. We'll revisit it in a second. Of course, that's the way demos just go sometimes. And so there's our attack flow. Send our data to Elasticsearch, and we're ready to go. Now, so the results. I ended up just over 1 million unique URLs were visited for the research for this particular presentation. And because I was sending now sometimes 5 or 6 different requests for each URL, we ended up with 6.5 million GET requests in this Elasticsearch database, or flat file index, really a database. So at this point, all the data I have indexed is totaling about 13.3 gigabytes of data. Now, the important part here, what did we find? What came of all this data? Well, the first thing, Python's request library is amazing. It is an absolutely far and away for scripting, requesting websites, it's the best. It's fantastic. And I found 2,547 total errors throwing this MySQL error at me. So out of 1 million, that's not bad. Not great, but not bad. 1,755 of those were unique. The reason being that they're not all unique is that in certain cases, I threw a malicious referral string and it also kicked an error. So certain websites were vulnerable to different headers attacks specifically. And here's kind of a breakdown of the findings. 852 were a backtick in the user agent. 607 were a backtick in the referral string. So you can certainly see the user agent string, more dynamic content is being generated from there than anywhere else. And we've got the cookies fields, 505 of those. Again, I was pretty stoked on that one. Lots there. And X forwarded for coming in just behind. And this regular quote mark, only 85 of those. So I don't know what was up with those servers, but they were vulnerable to a single quote mark getting thrown in there. Okay, so what does this mean? And you know, having these sites being unique, I had, when I initially set out to do this research, about halfway through, I said, hey, I'm going to make this talk called The Architecture of a Mass Injection Campaign. I wanted to know, you see this in the news, the Liza Moon attack, and these different mass SQL injection attacks, right? So my premise was that I wanted to see how those were conducted. I wanted to see if I could do the same thing. How do criminals do this? And as I got into my research on the first iteration, I wasn't exactly sure if it was going to pan out. And in addition to that, what I decided was I don't want my tool to just be around SQL injection. I want to be able to test for all types of different vulnerabilities in the headers, right? So I changed the name of the talk to large-scale header abuse. However, what came from this data and what's very interesting to find is what we really want are patterns, right? We want to see, of those 1,700 or 2,200 vulnerable sites, I want to find patterns. And what those patterns would be particular components. If I visited maybe 1,000 different websites that were running a specific Joomla component that was vulnerable. I want to see that, and that's what I found. And that's what's really exciting from the results of the research for me, anyway, is this Joomla stats counter. And I found quite a few of these. I started looking over it, and I went ahead and followed through to make sure it was actually injectable, and it certainly was. So this is a commercial Joomla component. Is everybody familiar with the content management system Joomla? Anybody? A couple people? So you can get all these third-party modules and add-ons, and this is one of them. People pay $150 for this module. Anyone running a version of this module, and there are thousands and thousands of sites, is currently vulnerable to this attack. So I haven't notified the vendor yet. I'll probably get around to doing that soon, I suspect, but they are vulnerable. I found another one, a common photography website one. There are thousands of these out there. So many sites running this are also vulnerable to injection through the user agent string. Is this going to be this? So now, I'm sure there are others out there. This is just the biggest patterns that I've found. So if I were a criminal now, and Haj was talking about this earlier, you know, the ways that how much money can be made and how they do this. Well, here's a perfect data set I have now. Now what I do is I go through and I go look at this Joomla component and I find a unique URL, and I go to Google and I say I want to see all websites where you've indexed this URL. And I could probably get a list back of a fair portion of the websites running this. It could be thousands of sites. Pipe that into a list, and I can start injecting them with code. Now from there, there's different ways that you can use that to profit and make money. In many cases, SQL injection can be turned into full, takeover of the server, command shell access. You'll probably see some of that tonight in the workshops in the next couple of days. But the possibilities there. There could be quite a bit of money made from this, from these vulnerabilities.